So I think in the last class, we just started with, which I think we are solving some problems on the design modifications that needs to be brought to obviate the sand course. Okay. So today I think we're going to complete that. I think we have covered sufficient number of problems on the casting design considerations. Okay, so today first hour I will just complete those. Another one or two problems are there, so let me complete those two things, and then in the fourth hour I will be starting today with the design consideration for welding. Okay, sometimes they may ask for you to give some theory questions based on welding design considerations for welding. So no problems on welding, so only the theory part I will going to cover it on in the fourth hour. Okay, so please, I think last class I had given one problem for you to solve. Okay, I hope you people tried this, and if you could not able to get so let us check the solution for this. Okay, so if anybody could able to get the solution, can just give me the solution, and let us just cross check the answers what we have from the textbook. Okay, so today let us start with that. I think this was the problem I think I have given for you. Isn't it? Yeah. So could you able to get the solution for this? At least have you tried this? How you can get the potting line, and how we can modify the design so that we can reduce or eliminate the need for sand course without affecting the weight and stability of the casting. Anybody? Have you given a try? No problem if it is wrong, nothing to worry. Anybody has tried, please check. Sandesh?
Yes.
Did you try? No. Okay.
So,
yeah, anyone. Sandesh, you can complete. I will come to you later. Yeah, Sandesh.
We can see the bottom part now, so we can place the fulcrum lever like that, sir. The parting line will be in the center, sir.
Parting line should be the center, right? Okay. What about the course, sand course required?
Only towards the right end we should use the sand course, sir, and rest of it we can do it by casting only.
Okay, whether we have to cast it solid, or we can generate the feature by casting only?
We can generate by casting only.
Right, let us say. Okay, that's it. Okay, Sandesh. Mohanambal, would you want to tell anything?
No, sir.
Yeah, could you able to give a try for this problem?
Yes, sir, I did, but I couldn't do.
You have to try, because in the exam we cannot say which type of problem you will going to get. Okay. So you should try. Once you try, then you will come to know where the mistakes you are doing, and then you can be confident enough for solving the problems in the examination. Don't expect the same kind of the components you may get. Okay, so because the problems is for not 5 marks or 3 marks, it is for 14 marks, 1/4. Okay, so a lot of things has to be done, and you should be very careful. So small mistake, definitely it may leads to the loss of 14 marks. Okay, right. So anybody, Sukrut?
Sir.
Yeah. Have you given a try for this problem?
It's as Sandy said, the parting line comes at the center,
Okay.
and the sand core in the right hand side, sir.
Okay. Let us check the solution now. Yeah. Look at the solution. Yeah. So first, the machine size of the hole means that the bosses will be cast solid, and therefore to keep the sand coring to a minimum, the preferred potting line is as shown in the figure. So exactly the potting line will be the center where the webs are cast and machine jaw has a sand core. So this is the one where we will go to get the sand core, right? Okay, right. So I think please make a note of these diagrams. So those you have tried, not an issue. If you not tried and if you could not able to get the solution, so please make a note of this diagram. So here one thing what you have to understand here is the bosses are being cast solid. So why? Because when you look at the hole what you are having, so it is around 20 millimeters on the left part, and on the center we have 30 millimeter diameter. Okay, so therefore according to the rule what we are following, so the size of the hole is less than 30 or less than or equal to 30 millimeter, it can be cast solid, and later part you can generate the hole by using a machining or drilling, what we call it as. So whenever we get the hole which is more than 30 millimeter size, then it needs to be the sand core is to be used. Okay, so therefore please look at these diagrams over here. So that's what you have to analyze the things very carefully in this kind of problems. See the bosses, in the sense this one I'm talking about, this portion. So this portion we will go into cast solid. So this and this both will be cast solid. Okay, and it can be machined later onwards, so that the hole what you are having, it is of 20 millimeter diameter on the right left side, and on the right side we on the center we have 30 millimeter. Am I right? So now once it has been machined, so you can drill a hole over here. Means once it has been cast solid, you can machine or you can generate a hole by using a drilling machine. So which is 30 millimeter, another one is 20 millimeter. So therefore we can get the hole of 20 millimeter size and 30 millimeter size by using a drilling machine. Okay, so therefore here you can avoid, so don't make the sand cores over here. So directly you can machine it. Okay, and directly you can cast solid initially, and then later onwards you can machine it. But what happens to this exactly at this point? So the size is 50 millimeter. When you look at this here, the size is 50 millimeter. So when you have f size is 50 millimeter, definitely we need to go for the what we call it as the sand cores. Okay, so usage of sand cores is very much essential in this case. So therefore, when you look at the diagram over here in the next slide, see here, so everything will be cast solid. Only the sand core is used here, is only here. Okay, and of course the potting line will go exactly at the center of the web. Okay, so please look at the diagram, look at the sizes of the hole, whether can you cast it or can you cast solid, and later part you can go for a machining, and the third one is whether it requires a sand course. So this is what you should be very careful while you are analyzing the things. Okay, and also they have please make a note of this diagram. This is very important diagram for you, the first solution. And the second one, what they say, figure shows H section webs rotated 90 degree so as to cast along the jaw. Also a plus section. This section for the webs gives same casting facility. So this is another one modification, modified design of a web section, sand core, not required again. The jaw, what I am showing here, the jaw here, this jaw, what I am talking about, the machining jaw, which is a machining jaw what we have. So which might be, so the small modification what you can bring over there is the H section webs rotated 90 degrees so as to cast along the jaw. Also a plus section for the webs gives the same casting facility. So this is the potting line what they are showing over here, and this is the positive as a plus web section, and this is a H web section. Okay, so without using a core for the jaw, that is a machining jaw, so you can cast the component without using the sand cores. So this is another one small modification what they have been showing in the design part. Okay, please make a note of these things. Okay, yeah. So if it is over, I will just move to the last problem today. So which requires another half an hour for you people to complete that problem. If you have completed means I will just go for the next problem. Shall I move? Shall I move to the next problem? Sandesh? Mohan number?
I did so.
Shall I move to the next problem? Is it over? Copying down that, noting down that the two solutions, so the design modifications, what we can bring.
Yes, sir.
Number?
Yes, sir, I wrote.
Yeah. Oh, right. We'll just move to the next problem, the last problem on casting design. So please look at this and try to solve the problem of your own. Okay. Yeah. Please note down this problem. See, there are two possible potting line. There are two possible potting line for a V-belt pulley. There are two possible potting line for a V-belt pulley shown in the figure below. Shown in the figure below. Indicate both of these. Indicate both of these along with the approximate sand course. Along with the approximate sand course. Accept that V grooves are machined from solid rim. Okay, next paragraph. While maintaining a similar weight and stability, of casting, offer a design modification to reduce or eliminate the need for sand core. So please make a note of this diagram. Again, this is a question which is asked once in your exam for 14 marks again. We build pulley. Okay. See here, this I think this dimensioning, I think is not visible properly. This diameter is 350 millimeter. See the last one. This is 350 millimeter. Okay. I think that is not visible properly here. It is 350. Please make a note of that. Is it clear, my dear students? Can you see these diagrams properly? The sketches?
Yes, sir.
Can you give me the solution for this problem now? So he says there are two possible potting lines for this. And one thing you should remember here is this V-belt grooves, sir, or V grooves, we can call it as V grooves. These V grooves are machined from solid rim. So no need for any sand cores for that. Okay. That's why he is specifying V grooves are machined from solid rim. Yeah, I will give another 5-10 minutes time. So write the diagram. Let us check how we're going to write the diagram. Please remember that the V grooves are machined from the solid ring. So means that V grooves, when you are casting, it needs to be a solid. Afterwards, you can machine it to get the V grooves. Yeah. Anybody were able to get the solution? Yeah. Anybody could able to get the solution? Harsha?
Sir,
Yeah. Sukrut? Could able to get the solution?
The parting line is at the center.
Potting line is at the center. Okay.
Yes, sir.
Then what about the sand cores?
Sand cores for two sand cores are required, sir, for the middle dam in the center and in the hole and for the center cavity, sir.
So you are talking about this cavity and the center hole.
Sir? Yes, sir.
This cavity. Am I right? So the cavity what we are having here, exactly at this point, and exactly at the center, we require a sand core. That
Yes,
is a one potting line. So any other potting line, there are two possible potting lines, he says.
ಎಲ್ಲ ಕೊಟ್ಟರು ಆಮೇಲೆ ಗ್ರೇಸಿಂಗ್ ಮಾಡ್ತೀನಿ ತೋರಿಸ್ತೀನಿ ಮಾಡ್ತೀನಿ.
Yeah, it is a one parting line. Subrut, what about other parting line? Anybody could able to get that? Sandesh?
Yes, sir.
Yeah. Okay, Mohan Ambal, could you able to get the solution?
So why we need two webs? It's a pulley, no, sir.
Doing so.
Yeah, it is a pulley. Yeah.
We can make it as a one big web, no, sir.
Sorry?
Instead of two webs, we can do a one big web. Increase the thickness of the web and put it at the center.
Okay.
Pulley has only one web, no, sir.
Okay. So we will just look at the solution now. Look at this solution now. There are two diagrams we can showing here, the two different parting lines. Yeah. Look at the solution. You just understand the two different sketches over here. Figure 1 and figure 2 they have given. Yeah. So what do you understand by this? What is the solution you can, the diagram, what it is showing? Anybody can explain? The figure number 1.
So the parting line is along the shaft, sir.
Okay.
And for the center, they have used the sand course, and for the outside two gaps, they have used casting iron.
Yes, very good. Then he says difficulty in core removal.
Yes, sir.
What is that? Yeah, anybody can answer, no problem. So in the first figure, what you can understand here is the potting line is on the whole axis. So here we have the through hole. If you look at here, this is the hole of 30 millimeter diameter. Okay, so this is a through hole. So now in the first diagram, what they are showing, the first possible potting line will be the potting line which passes through the axis of the hole. Okay, so that's what the figure number 1, what it is been showing. So to get that, we need a sand core exactly at the center to get a hole feature. And apart from that, so all the interior surfaces, so we require a core. So in this position, it's not so easy to remove the sand cores out of the mold cavity. So now what he says, let us change that the potting line direction to perpendicular to the whole axis. Perpendicular to the whole axis. Look at this, the second figure, what you can see over here. So please, that is potting line transfers perpendicular to the whole axis, which will require sand core for hole and central pocketing. So I think what he suggests is this kind of method of casting, making the potting line exactly perpendicular to the whole axis, will give more easier way to remove the sand cores compared to the previous one. Okay, this is the two different potting lines you can observe over here. Look at this. Look at the two sketches over here and try to understand what's going on there. Okay, so one is exactly along the axis of the hole, another one is exactly perpendicular to the axis of the hole. So what it says in the figure number 1, so the sand core is required for the hole as well as the interior surfaces. And in such cases, so when you have a core is exactly at the along the axis of the hole, so it is difficult to remove the cores from the mold cavity after creating sand core mold cavity. So it is very difficult to remove the sand cores from the mold cavity. So therefore, he says the second one is the one where the potting line has become perpendicular to the whole axis. See, this is the potting line, what he says. And this is the sand core used for creating a hole. Okay, and of course, here also we require the, what we call it as the sand cores. Sand cores is required for central pocketing. So I think this is the best method what he suggests for generating the V-belt pulley by using a casting. Okay, so these are the two different potting lines what he suggests for this. So please make a note of these two diagrams and try to explain which is the best one, okay, by the modification or what you can bring to this. Okay, so please make a note of these two solutions. So I think we just completed these problems on casting design considerations. Okay, so please concentrate mainly on the problems. So theory, they may ask for around 5 marks or 6 marks, but the majority of the marks out of 20 marks will going to get a problem. So definitely the problems for 14 marks. So when I just look at the question papers, previous year question papers, so in all those question papers, we are getting the problems for 14 marks. So please be careful. Okay, try to write the diagrams neatly. Don't do mistakes in writing the diagrams. Okay, so please indicate whatever the labeling what you're supposed to do, and also please specify whether the sand core is required or not, and please remember that. So for what size of the hole we require sand core, for what size we don't require sand core. So whether we cast it solid and later we machine it the hole, or we can have to cast it, or we have to use the cores. So this is a very important thing, and most marks you are going to get the marks on this chapter. Okay, so questions will be very simple, but and of course answers also little bit of thinking you had to do, and a little bit of neatness you have to maintain while you are drawing the diagrams. Rest of things, I don't think it's not such a difficult thing you can have. So please try to solve the problems of your own. Okay, and of course don't expect the same kind of problems you may get for exam. So small changes they might bring, or they may take from some other textbook, and they may give the component and they may ask you to solve the problem. So in such cases, you should be in a position to solve it, because it carries 14 marks. It is not 5 marks or 10 marks. It is of 14 marks what they will going to ask. Okay. So I think we completed the first part of the module 2. So that is the design considerations for casting. Okay, so I think we have done with the number of problems also. Okay, so please if you have textbook Harry pack, so you can just look at the diagrams, look at the exercise problems, and you can just try to solve of your own. Okay, any clarification in this regard to anybody you can have here, because from fourth hour, from next class onwards, I'll be starting with the design considerations for welding. Yeah, Mohan Ambal, any clarification?
No, sir.
Sukrut?
No, sir.
Sandesh?
No, sir.
Harsha?
No, sir.
Okay, so please have everything, your solutions, you write it down in your book. Okay, so of course it will be there in your YouTube channel also. You can look at the videos. Okay, and of course I will go to post these PPTs in your Google Classrooms also. But whatever it might be, you have to learn, and you have to write it and learn. Simply, you cannot just look into that PPT or notes. You cannot do. You have to practice. You have to practice once, twice, thrice. So then only you are going to get an idea. And more important thing is, you need to have a little knowledge regarding the casting or machining or forming or welding. These are very basic things you need to remember. We have the basic knowledges of these manufacturing processes, and also you should think of how the manufacturing processes will be carried out. Okay, so a little bit of common sense and a little bit of knowledge, if you have, definitely these kind of problems can be solved with very easily. Okay, so any clarification to anybody, so you can ask. Otherwise, so we will just wind up today. And in the fourth for this class, I think, sorry, for this class, and in the fourth hour, I will be starting with the design considerations for welding. Okay.
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 Sure.
So okay, that right. So join on the same link for 11:50. So where I will going to start with the design considerations for welding. Thank you. Thank you very much.
Thank you.